Hello! So today I'm going to talk you through how to do part B of your DNA to disease project. So I'm going to walk you through how to make and read pedigrees and how to make and read Punnett squares. So if you're struggling with that part of the project, I'm happy to walk you through it now. So first thing we're going to do is learn how to make and read a pedigree. So what a pedigree is just this kind of family tree looking thing. Which is just a diagram that shows the inheritance of a trait over several generations. So there's a little key here to show you what the symbols mean. So the squares are males, circles are females, and the ones that are shaded in means those are the ones that have the trait or they have the disease, so they're affected. Unshaded means they're not affected, so those are the normal individuals. When there's a line in between them, that means they've had children together. And if they come down from a line, the same line, that means they're siblings. Okay? So I just want you to pause the video for a second and see if you can read this pedigree and answer these questions just as if this was a do now in class. So go ahead and pause the video for a second, see if you can try these, and then we'll go over them. All right, so hopefully you tried this, and here are the answers. I filled them in for you. And what this essentially means, what is the gender of individual 3.1? 3 refers to the generation, so that would be this number here. So generation 3, person 1, so that's this person here. So since it's a square, that means this person's a male. What's the gender of individual 2.4? So generation 2, number 4, that's a female because it's a circle. How many girls have the trait? Means how many circles are filled in, right? 2 females have the trait. Boys that have the trait, we've got 3. Okay, you can look at the rest of the answer key yourself to check the answers. I don't want to waste too much more time. So the agenda for this video, the first part of the video, I'm going to walk you through making and reading pedigrees. Then you can take a break, work on the pedigree portion of part B of the project. And then for the Punnett squares part, that's part 2 of the video. And you can use that to help you complete the Punnett square for your patient on your part of the project. Homework for the week is just to continue working on the project, so you'll have 2 weeks at home to work on this. You have plenty of resources in the Learning Genetics folder, as well as this video, as well as your textbook. I'll be checking these over the weekend, giving you feedback on whatever you've done with the slides, so make sure you're doing something, and I'll give you feedback of how you can improve. The entire project will be due the 17th, so you have 2 weeks at home to complete this if you haven't done so already. If you have done so, relax and take a break. You earned it. So what is a pedigree? It's a diagram that shows the inheritance of a trait over several generations. So again, kind of like a family tree. And it only shows the phenotypes. Remember, phenotype is the physical trait. So we don't know the genotype, we don't know the genes of these individuals. We only know, do they have the disease or do they not have the disease? So the important thing that we're doing with the pedigrees is we're going to be able to identify, is this trait either autosomal or X-linked? Autosomal means it's on one of the regular chromosomes, right? We've got 23 pairs of chromosomes. 22 of those are autosomes, so a non-sex chromosome. X-linked just means it's on the X chromosome, meaning the chromosome that's determining your gender. Females are XX, males are XY. We're also going to be able to figure out, is this trait dominant or recessive? And there's a little picture here. I'll move my face so you can see dominant letters are usually shown with a capital letter. Dominant genes, I'm sorry, not dominant letters. And the recessive genes are shown with a lowercase letter. Those are the weaker genes. We'll go over that when we get to the Punnett squares section. Okay, so let's figure out how to tell if the inheritance of a trait is X-linked or autosomal. So there's a couple things that we need to look at. So if there are many more males that have it than females, that means it's X-linked, because males only have 1 X chromosome, while as females have 2 X chromosomes. So if a female has an X-linked disorder, she has to have 2 recessive traits, 2 recessive alleles, whereas the male only needs 1 because they only have 1 X. So males get X-linked traits more frequently. So if a disease appears more often in males, which are represented by the squares, than the females, it's X-linked. In this case, we've got 5 males that have the disease, 3 females. So there are more males, but there's not that many more males. So let's look at a couple other things that'll help us figure this out. If it's X-linked, if a daughter has it, her dad will too. Okay, so let's look at the daughters. This daughter has it, and her dad does. This daughter has it, but we don't know what her father has because her father's not on here. She's the spouse of this male. This daughter has it, and we don't know if her dad does because her dad's not on here either. So let's keep looking. If a mother has it, her son will too. So this mother has it, both of her sons have it. This mother has it, both of her sons have it. So that means this trait is X-linked because there's more males that have it. If a female has it, her father has it, and if a mother has it, the sons have it. So it follows all of these rules. So when you make your pedigree, these are the rules you need to be following to figure out, is it X-linked or is it autosomal? This particular one is X-linked. Now we need to figure out, is the gene on the dominant allele or the recessive allele? Remember, dominant is stronger, recessive is weaker. So these are the questions we need to ask ourselves. Ask yourselves, are there carrier parents? Carrier parents means they're unaffected, but their children have it. So if we look here, these parents are unaffected, they don't have the disorder, but one of their children does. Same thing here. The parents don't have it, the kids do. That means the parents are carriers, so they would have a heterozygous genotype, meaning a capital letter and a lowercase letter. And if you're not sure on a lot of these vocabulary words, there is a Quizlet where you can practice and then come back to the video. So if there are carrier parents, like in this example, then the trait is recessive, meaning it's on the smaller letter, so a lowercase letter. If there's no carrier parents, so for example, if a kid has it, their parents also have it, that means it's dominant. Another way to think of it as it's going to be in all of the generations. It's not going to skip a generation, whereas this one skips a generation. There's only no effectiveness on the grandchildren in this family tree because the parents don't have it. Right? If the parents don't have it, the kids aren't going to have it. Okay? Okay, now take a second, try to figure out these pedigrees, which one's dominant, which one's recessive. If you guessed that the one on the left is dominant, you're correct. It appears in every generation. There's no carrier parents. Where the one on the right is recessive because it skips a generation. There are some children who have it and their parents do not have it. That means it's carried on the recessive allele. So now what we're going to do is we're going to apply what we just learned to our project. So go to your unit project, DNA to disease, and we're going to click on part B, which is this one, the part B template. So when you get into the template, you are going to find your patients. Okay, so whoever your patients are, if your patient is Sunny and Sophia, that's the only one you're going to read. You're not going to read the other patients. Obviously, if this was in class, I would have printed these out for you, so you wouldn't have all of the other ones, but that's not the case. So find your patients and create a Punnett square with your 2 individuals, right? Ashley, the woman's name is the patient I originally gave you, and the other person is the person that they're having a baby with. So you need to make a pedigree for both of these, and you would connect them in the middle. Okay, so how you can do this is you can insert, nope, oh, I can't do it on here, can I? You can do this more easily on yours because this is in a Google Doc. It's not on Google Slides. Here, let me show you on Google Slides. Hold on a second. Okay, so I'm going to show you super quickly how I would start a pedigree using the information. So it says, I am not affected. So you can click on these shapes here. And this is the male, so I'm going to use a square. I'm not affected, so I'm going to draw a square in the middle because you want your individual, so you'd have a circle on the other side for the woman who this person's having a baby with. So this is representing my dude. I have one brother and one sister, both are unaffected. So I've got one brother, I'll insert another square. And one sister, I can now do a circle. Neither are affected, so I'm not going to shade them in. And you can also use these lines, right, to show that they're siblings. So you can, oh dear. Obviously, I'm not an expert at this. If this is too much of a pain in the butt, you can also just draw it on a piece of paper and take a picture of it. I'm just going to draw a little bit more so you get the idea. Another line. Oops, come on. Here we go. Okay, so those are showing that they're siblings. And then when you do their parents, you would make another line coming up, and the parents on either side. Blah, blah, blah. You kind of get the gist, right? Another square for dad, another circle for mom. Okay? If you have more questions on this, I'm happy to go over it either individually or during our Zoom meeting. Okay, so at this point, pause the video, go back to part B of your project, and see if you can make a pedigree for your patients. Take your time. If you need to rewatch the video, go for it. But that should be able to help you get through the pedigree portion. If I was confusing, I also put a second video of someone who's less confusing than me.